Hello everyone. So today we are going to talk about how to create tables in different ways with PostgreSQL. So first we are going to create a simple table with 5 columns. The first column is student ID with data type integer, which is whole numbers. The second column is student name with varchar, which is the length of 100 characters. The third column is student GPA with a decimal value with 5 digits and 3 decimal points. The fourth column is student enroll date with the date value, and fifth column is student graduated detail, which is a boolean value, so we can put yes or no or 1 or 0 value. So first let's create this table. So here I'm going to use PostgreSQL shell, or you can also use the graphical user interface also. For the server is localhost, yes. Database is Postgres for now, yes. Port is 5432, yes. Username is also Postgres. Okay, the password, we need to give the password that we have created before, so I'm giving mine when I used at the installation. Okay, so I am in to the Postgres database. So let's see what are the databases that we have. As you can see, there are three databases: Postgres, template 0 and template 1. For our purpose, let's create a new database. So how to create a database? We can use create database. Let's create a test database with the name of test, and yes, it is created here. So let's see again our databases. Yes, we can see test is there. Let's log into this test like this, and now we are logging to the test. Let's create the table first. Okay, so what's the table? Our 5 column table. Create table. Table name is students. Okay, so our first column is student ID, which is integer. Then student name with varchar 100 characters long. Okay, then student GPA numeric with 5 digits and 3 decimal points. Student enroll date, which is a date value, and student graduated with a boolean value. Okay, that's it. Let's press enter. Okay, table is created. So now we can see our tables in our test database like this. We have one table which is students. Let's describe our table like this. So you can see it has 5 columns with these data types. So now we have created this table. Let's get into the next slide. Now we can add a primary key to our table. So what's a primary key? A primary key is a column that has unique values for each row. So by a primary key, we can uniquely identify each row in a table. So how we can add a primary key to our table? So let's say our student ID can be primary key. So student ID integer primary key like this. Also there are auto increment primary keys. So we can add serial keyword to add the auto increment primary key to our table. You can see the table is structure. We can add a primary key like this. As you can see, student ID is integer and there are nothing in this column. So we are going to drop this table and create it again. Okay, let's drop our table, drop table. Okay, we drop the table. Let's see if it's there. No, it's not there. So let's create the table again with the primary key. Create table, students, student ID, integer, primary key, and we can add other columns with the up and down arrow keys, so we don't need to type all the things again. Student name varchar 100, student GPA numeric 53, student enrolled date, student graduated boolean, and yes, the create table is created. So let's check the table, like if it's there like this, and yes, it's there. And let's describe our table. Student, yes, it's there. The primary key column, which is student ID, is not nullable, and student's primary key is added, and it is showing it's an index here. So now we need to add an auto incrementer primary key. So we are going to drop the table again and create it again with the serial primary key keyword. Right, we dropped it. Now there are no tables here. right? So we need to create it again with the serial primary key keyword. So we do not need to type it all again. We can use up and down arrow keys and take back what we have typed before. Okay, create table students, yes. Then we will replace this integer with serial, student name, student GPA, student enroll date, student graduated. Okay, table is created. Let's see if it's there. Yes, it's there. Let's describe it again. So we can see here the table description has changed like this, as you can see here. Now auto increment is there. What we can do here is insert some data and check if it is auto incrementing. Let's insert into students. What are our column values? Student name, student GPA, student GPA. Let's add 3.02, specify a date in this year. Okay, now we have inserted the value like this: GPA 3.02, enroll date November 10th, graduated now. So let's see if data is there. Select everything from our students table. Okay, we can see student ID is 1 and name is John and our data here. Okay, what we can do here is add another field and see if our student ID increments to 2. Okay, insert it. Let's select them. Okay, now we can see our student ID is incrementing automatically because we have not mentioned it here. Next, we need to talk about timestamps. We use timestamps to record creation and record updates. So imagine if you are having a system, and in that system, like maybe Facebook, you need to know when a record is created, what time that record has created in your database. Like for example, in our table students accounts, we can insert account ID, then when account created and when was last login to that account. We can store those details in a separate table. Like our students in previous table, they have created an account in our system. Now they are going to log into the system. So when they create an account, we insert the timestamp which includes date and time. We record their last login details in here, again date and time. So we have how many tables? Just one table. Let's go and create the second table. Create table, student accounts. Okay, first one is account ID, which is an integer. Maybe we can use and a primary key. Next column is created on. When is the account created on, and we are going to store the timestamp. And the last login column, it is also a timestamp. Table is created. We can see all the tables here. Now there are students table and student accounts table here. We can describe our table like this. Okay, we can see the primary key here is added as an index. So let's try and insert some data to our student accounts table. So here we can insert our data into the student accounts table. We can specify the account ID, then we can specify last login and account created. We can specify the time, it is now. Okay, we can insert our data like this. John created the account right now and he last log into the account right now. So we inserted that. Let's check it. Okay, as you can see here, the timestamp is there. This is the current timestamp with even milliseconds, right? Okay, so now we know timestamps. Let's create a sub table here. So what's the sub table? We can create a table with the use of an existing table. So how we create a sub table? With this statement, create table, and then a new table name, then the as keyword, and then select statement to where we can select our data and put in our new table name. So we are going to create a table called first class students, and what we are going to do is we are going to select them based on their GPA. So as we can see here, this is our students table and we have two records, one having 3.02 GPA and one having 3.12 GPA. So what we can do here is we can write a query to select Jessica's data into our first class student details. So let's assume Jessica is going to get the first class, so let's write the query. Okay, so we can create the table like this. Create table first class students as, select student ID, student name, student GPA from students where student GPA greater than 3.10. Okay, it is selected. Let's see if there is another new table. Yes, we can see first class students table is there. Let's check it. Of course, Jessica is in the first class table and John is not there. So let's create or replace a view. So like in MySQL or other databases, we cannot create or replace a table. We can only create or replace a view in PostgreSQL. So view is a virtual table, but it is a permanent one. Let's create a virtual table called late enrolled students. The columns are student ID, student name, and student enrolled date. ID, student name, and student enrolled date. From students where student enroll date is greater than or equal to some specific date, so 10th, something like this. So what we did here is create or replace a view which is called late enrolled students, and we selected the data details from student ID, student name, student enroll date from students table, and we specified a date if someone has enrolled after that date. They are in our view. So let's see our view. Here we can see late enrolled students are in a view. Let's select it. Okay, we can see John. Why is that? John has enrolled in November 10th and Jessica has enrolled in 10th October. Okay, that's about views. So we can then go to alt table statements. So what is altering a table? Altering a table means we can modify or add something to a table. We can modify data types, names, or constraints. For example, we can add a column called faculty to our students table. Maybe we can rename our entire students table as a new name like current students. So let's do that. First, let's add a new column called faculty. Okay, we are going to describe our table, which is the students table. So this is our students table structure. There are 5 columns: student ID, student name, GPA, enroll date, and student graduated. We are going to add a new column. So we are going to use the keyword alter table, students, then keyword add column. Okay, column name faculty. We can specify data type, varchar, maybe 5. Okay, table altered. Let's describe it again. As you can see, faculty is added here, wearing character 5 length. Okay, so we can rename our table. So before that, let's list our tables here. With DT, we can see first class students, student accounts, and students table. Let's rename our students table, alter table, if exists, then our table name, students. Then we can use the keyword rename to and specify our new name. We can rename it to current students, and let's see. Yes, it is altered. Now let's see our table list, and we can see our students table has renamed to current students. Okay, so next we are going to talk about importing data to our tables. Here we are going to import data from CSV file. So what's a CSV file? It's a comma separated values file, which means two data items are separated with a comma. In this case, however, the comma is called a delimiter, and we can specify the delimiter, which means we can use any other symbol instead of comma if we want. And we need to specify the absolute path, which is the path to where our CSV file lies in our computer. And we need to specify the header keyword so the database know that our CSV file has header values. Also, before importing a CSV file, we should have created the table that we intend to import data. Let's create a simple table called student address, and we can add student ID and address there, which is an integer, and student address, which we can use a var value, maybe 100, it's fine. And now we have created a table. Let's see our tables. Okay, we can see the students address table here. Let's try to describe it first. Two columns, student ID, student address. Now what we can do here is create a CSV file. For that we can use an Excel sheet. Okay, here in our Excel sheet we can create our two columns, student ID first one, and then second one is student address. And we can add some values like student IDs and addresses are like city names. Okay, we can add some values like this as cities, and then we can save our file. So if you open our CSV file in a notepad, you can see that all the details are comma separated, right? So that's our delimiter. So let's write our query and import that data. First of all, let's see if there's any data in our student address table. So let's select everything from student address table, and we can see there are 0 rows. So let's import it. So we can specify it with a copy command like this. Copy, then our table name, which is student address, then our location from inside here. I have stored it in D drive, so I'm specifying it like this, data.csv. Then we need to specify delimiter, which is a comma, and CSV header. PostgreSQL knows there's a header and there's a delimiter like comma. Then it will import our data. Okay, it's done and 5 rows have copied. Let's try our select statement again. Okay, as we can see here, student ID, student address are all there. So now you know how to import a CSV file into a table. So let's talk about indexes. This index is same as like a books index. It helps us retrieve data faster. Index arranges column values in order, so that is why it is fast. So there are two types of indexes, clustered index and non-clustered index. Clustered index is primary key. When we create a table and add the primary key column automatically becomes the clustered index. So we can make other columns also an index. When that happens, those columns are called non-clustered indexes. So index need a name, so we need to give it like create index keyword and index name, then on which table and which column we are going to make an index out of, right? So let's make an index in our students table other than our primary key. So here we know that we have few tables like this, and let's go to our current students. We have renamed it, right? Let's describe that current student table so we can better understand what's an index, right? See, we can see that there's a default index to students primary key. So let's make the student GPA an index. Create index, then index name. Let's give index GPA. Then we need to specify the table, which is our current student table. Then our column name, which is student GPA. Right. So we have created that index. Let's check it. See, now we can see that there are two indexes here in our table, which is primary key and index GPA that we created. Okay. So this primary key is a clustered index, and the other column we created as an index is a non-clustered index. So let's talk about constraints now. Constraints are specific limitations that we put into our columns in our table. So there are two types of constraints, column constraints and table constraints, which are all applied same. Like when you put a constraint into a column, that is a column constraint, and when we put a constraint into an entire table, which is a table constraint. So primary key can be used as a constraint like student ID, then we use maybe serial primary key or something, or integer primary key, then it is a constraint. Not null is a constraint, which means we can specify our column name, then its data type, then we can put not null. Not null means we cannot put a null value, which is we cannot make this column empty. The next constraint is check, which is also a constraint that checks a value before inserting into a column. Like you can see, student GPA is a numeric, and it is also specified as not null, and with check it checks if student's GPA is 4.0 or lesser. So if someone try to enter a GPA value which is greater than 4.0, it will output an error. Also, in terms of table constraints, this table constraints comes after the column list when we create a table. Like primary key, we can specify primary key is this specific column. Then foreign key, we can specify foreign key is this column, and it has references from this tables, this column, right? Then we can also use check, but we cannot use not null, so we need to use is not null keyword here. So when we use check, it is checking that if created on column and last login column is not null, which means when someone is creating an account or when someone has logged into an account, the software should insert these fields. Okay, let's drop our student table and then create it with not null values and check constraint. Okay, so as you can see, we cannot drop the table directly because we have the dependence of that table. So we need to use this cascade keyword. So we used drop table current student with cascade keyword, and now it is there. Now we have dropped it. Let's check. See, now all the dependents are also gone. So let's create the table again with not null and check. Student name, Vacha 100 and could be also not null. Then student GPA, numeric 5, not null. Also we can check if it is inserting GPS lesser than 4.0. Then we can add the student enroll date, and also we can specify that it is also not null. Okay, student graduated, boolean not null. Faculty, Vacha 5, not null. Okay, we created the table. Let's check. Yes, we can see student table. Let's describe it. Okay, we created the table. Let's see. So here we can see new values added. These not null fields, and we have our check constraint after the index, which is for 4.0 GPS. Right. Let's insert a value. Okay, we can insert it like this. The name drain and GPA is 4.4 and the date and other things. So if the check constraint works, we cannot insert GPA values greater than 4.0. Let's see it. Okay, now there's an error and it is saying new row for relation students violate check constraint student GPA check. Right. So what we can do is we can insert the same value with the GPA lesser than 4.0. Let's insert like 3.9 and check it. Yes, we can insert it. Let's check for not null values and we can skip the faculty. Okay, there's an error. What is the error? Null value in column faculty. So we cannot insert null values. So we need to have values there, right? Students table, we can insert it. Let's check our table. It's there. Student ID for Johnson, maybe now GPA, computer science. Okay, we can check our table constraints also. For that, we can drop our student accounts table and create it again. Okay, let's drop it first. Let's see our tables. Our student accounts are not there. Okay, let's create our students account table again. Account ID is integer. Created on is timestamp. Last login is also timestamp. Then the primary key is account ID. We are specifying it now like this. Then our foreign key is account ID from our table, and it refers to student ID in students table. And our check constraint works like this. It checks the created on column is not null and last login column is also not null and the table created. Let's see, here are our tables, student accounts table. Let's describe it. See, now we can see the primary key is also index. There's a check constraint and there's a foreign key value here. Finally, we can talk about temporary tables. These temporary tables can be created, but it will automatically drop when your session ends, which means you log out of your database. We can use the keywords temporary or temp, which is easy to create the table. Create temporary table, and we can specify our table name, and with the as keyword we can use a select statement. So let's create a temporary table. So we can create a temporary table like this. Create table, table name, temp We can say students in our keyword, and now select this statement. We can select everything from our student table and put it here as temporary. Which table? Students. Okay, it's there. Let's check our tables. See, the temp students table is created. We can see that in schema details it is specified as pd temp for, others are public. Okay, let's describe it. We can see it is specified as a temporary table, and we have all details from our students table. All right, then that's all for today. Thank you for watching.